Hello everyone, welcome to the channel, the Math Tutor channel. Today we are going to talk about some physics, and we are going to look at how to derive the equations of linear motion. As you can see the heading, um, in physics we have different types of motions, different types. There's what we call linear motion, motion in a straight line. Like you see the name linear, motion in a straight line. We have circular motion, motion in a circle. We have simple harmonic motion, okay, motion through a fixed point, and many more, okay. But today we are going to focus on how to derive the equations of motion. Now, the equations of motion are applied at different levels of education of physics, and also they are applied at different both in math and in physics. So different curriculum, IB, IGCSE, GCSE, Excel, whatever. So you just have to understand how to derive them, okay? And after understanding how to derive them, you will also understand how to use them to solve questions, right? So we shall start immediately. So we shall start with the first equation. Okay, so according to Isaac Newton is a scientist who studied motion, linear motion, motion under gravity, and came up with three laws. Okay, and the three laws will be in another video that we shall talk about. But in this one, we are going to talk about mainly the equations of motion. Some books say there are four equations, but they are basically three equations, right? The fourth equation is within the third and second equation. We shall talk about that. So the first equation is got from the idea of the definition of acceleration. So we know that acceleration is the rate of change of velocity okay, rate of change of velocity. Some can say with time, or they can just say with velocity, because the fact that you mention rate is something to do with time. So if you say rate of change of velocity with time, it sounds like a repetition, but it's not reprimanded. It's okay, you can still get the points. All right, so let's say rate of change of velocity, and we know that the notation of acceleration is a, and velocity, if a car is moving or a particle is moving, right? Let's write that assumption as well. Let's write that assumption that if a particle is moving at an initial speed. Now, there's a very slight difference between speed and velocity. Okay, speed has no specific direction, but velocity has a specific direction. Therefore, speed is a scalar quantity, and velocity is a vector quantity. So here, the word speed can be used interchangeably with velocity. Okay, and the initial speed is always represented, or the initial velocity is always represented by a u, and reaches its destination with velocity okay, with final velocity with final velocity v. Okay, the final velocity or speed, by the way, I should also write here the word speed. They can be used interchangeably. V at a time t. Okay, So acceleration then will be the change, the rate of change. So v final speed minus initial speed with t, like over t. So this is acceleration. So from this we can make v the subject. Okay, we can make v the subject by multiplying both sides by t. So you multiply by t, like that. So we have at is equal to v minus u, meaning that v will equal to u plus at. So this here is the first equation. This is the first equation, okay, of motion. Okay, this is how it is derived. Now let's go to the second equation. So second equation of motion, okay, we of course we shall put into consideration this particle that we talked about with the initial and final speed and at the time t. Alright, so as we continue we shall say that displacement, okay, displacement is also the same as distance, but the difference is displacement is a vector quantity, it has direction, and distance is a scalar, it doesn't have direction. So displacement is equal to, we can say, average speed times time. Just like distance is equal to speed times time, this one is average speed times time, or yeah, just average speed times time. Alright, so you can rememorize this. DST means distance is equal to speed times time. Speed is distance over time, and time is distance over speed. Alright, so since we have two velocities, okay, it's better, since we are using displacement, it's better we use all vector quantities. So we use average velocity here. Makes sense. So the average velocity, average like that, velocity, average velocity is v plus u, and since there are two velocities we divide by 2. So this here is the average velocity. Okay, now displacement in physics is represented by two symbols. It can be an s or an x. So let's use an x because s may be interpreted as speed. Okay, so we say let displacement equal to x. So x will be v plus u over 2. This is the average velocity times time. The symbol for time is this t. Okay, but you remember from the first equation, v is equal to u plus at. Okay, so we can now replace just a minute, just a minute. Okay, we can now replace the v with the u plus at. So x will be u plus at, and then plus u all over 2 into t. As you can realize that, this part here is the v. Okay, we have substituted the v, and we can now multiply the x inwards, like into the bracket. So we have ut plus at squared plus ut all over 2. Alright, so this ut here, I'll highlight it so you can follow clearly. This ut, oh, this color is not good. I'll get rid of it. Just a minute. Okay, I'll highlight it with a better one. So this ut and this ut are like terms, so they will be put together to become 2ut plus 8t squared all over 2. Okay, so a fraction with a common denominator is exactly the same as writing that fraction okay, with the denominator split. Okay, so these 2 can cancel with that, and what we remain with is what we call the second equation of motion. So x will be ut plus at squared over 2. So this is the second equation of motion, linear motion strictly. Alright, so let's talk about the third equation. Like we said, there are 3. The third equation will be putting into consideration our assumption that we wrote in the beginning, that initial speed is u, final speed is v, or velocity is v, and the time taken for the whole journey is t. Okay, so we already know that displacement x is average speed times time. So we already know that average speed is u plus v over 2. Okay, and from the first equation, v is equal to u plus at. Okay, t will be v minus u over a, like making t the subject. So x, which is a displacement, will be average speed times time. Okay, time is now v minus u over a. Okay, so let's simplify this. So x will be, multiplying this will be uv plus v squared minus u squared. Okay, uv plus v squared, and then okay, this is minus u squared, and this will be minus uv, then all over 2a. Okay, now multiplying both sides by 2a, so we have 2ax equals, here it will cancel out, and this will cancel out, so we have v squared minus u squared. So taking the u squared to the other side, we shall say v squared is equal to u squared plus 2ax. Now this here is the third equation, of motion. Okay, so I hope the explanation was clear, and I hope you understood how to derive these 3 equations of motion, linear motion to be specific, and I hope this helps you in your studying. Subscribe, like, watch, share, and see you in my next video. Have a nice time. Today I decided to talk about physics. Bye bye.